and welcome to the sixth book of the CodeRunner series. I'm here with Emrah Uslu.
Hello, my name is Emrah Uslu.
And today we're gonna talk about DynamoDB and NoSQL, programming with NoSQL databases in AWS. Let's go to the agenda. Let's start the. Yep. We're going to start with what is NoSQL first, because that's a hot topic too. And we're going to introduce you to the DynamoDB a little bit, and we're going to take a look at how to scale that service, because it involves a little bit of math in it. So after that, we're going to create a database, in table actually, in DynamoDB, and talk a little bit about the DynamoDB stream. And at last, we're gonna have a demo. We're gonna create a table, we're gonna insert a record in it, and we're gonna try to retrieve it within the AWS SDK with .NET Core and AWS actually. So, what is NoSQL? It's a non-relational distributed database perspective actually. We have our DBMS a long time ago, and we still have do actually, but about 4 or 5 years ago, NoSQL came up. That point of view came up and changed the whole world.
Yeah, MongoDB is one of the most popular NoSQL solution.
Yes, and AWS provides us one too. It's called DynamoDB, and actually NoSQL has no data type in it.
It's non-structural.
Yeah. That's why it's called NoSQL.
Yeah.
And because of that, it provides us with high volume of operations, because there is no actually asset operations. It has no asset operations. Some of them actually supports, but not all of them. So let's look into the DynamoDB. DynamoDB is fully managed NoSQL service AWS provides to us. It supports document or KW type of values in it. It scales the inner workload as long as you give it a sufficient scale actually. And it's fast, it's consistent, it has access control with IAM actually, and it's event driven. We're gonna take a look at in maybe next sessions, but it's actually mentions about a stream, a DynamoDB stream. It's event driven.
What kind of document is it? It refers to?
Actually, document maybe not all of them, but actually a lot of them supports the JSON format.
JSON.
And DynamoDB is no exception. It stores the data as a JSON document, and KW is maybe the same. So, AWS, how AWS offers us high available NoSQL databases, it's actually distributes your data in 3 different availability zones, and only acknowledges the write operation if 2 of the availability zones has that in their disks. So it's actually a very resilient service. That's all actually. So About the scaling, so scaling is a little bit of, as we said before, includes a math because you have to calculate write and read operations separately and came up with that number to give as a partition to the AWS service. Read capacity and write capacity actually depends on that, and they are measured in on writes kilobyte, 1 kilobyte per second, and for the read 4 kilobytes per second. And this is the formula actually. A single partition. Actually, you when you calculate that formula, it outputs a number, and that is actually a number of partitions that you require for your operations, for your solutions, because it calculates the read states and write states and merges them between to calculate the partition count in the AWS. And one partition approximately equals to 10 gigabytes of data. So do the math for yourselves. And for the creating database process in the AWS console, this is the page that pops up. We're going to take a look at that page in our demo, but we will see this right now. Primary key, you have to provide it a primary key. You can name it whatever you want. That actually calls back to your records primary key. That's a primary key. What else to expect? And you can choose string or number or binary and make that as your records primary key. You can also add sort key into that. That way, when you fetch the data, it sorts by that, and you can maybe add timestamp like this example too. So that is the next page. If you uncheck the defaults, you have to provide a read capacity unit and write capacity unit as we talked before, and it defaults to 5. You can change it whatever you want. And next, this is the edit page. It actually creates a order table. In that you can create an item and put whatever data you want, and it will actually show you that data in that page. Or you can, like we will do, you can actually fetch that data and use it programmatically.
And because if I store it as JSON, I can store a related item bound to this order item, right?
Yeah.
Is it possible? So in a normal SQL scenario, I create 2 different tables, and then when we fetch them, join them. And in NoSQL world or in DynamoDB, I can put it together and put it on just one table.
Store them in between.
Good.
That is also can do. About the string, Dynamo string, it's actually a log. It's just a log, but logs on steroids. You can have these logs up to 24 hours and process them actually. It creates a log for creating an item, updating an item, maybe deleting an item, and you can do lot of things with that kind of capacity. You can use it as a maybe IoT, because you can use these type of scenarios in your maybe IoT type of
Actually, this feature is useful for the event-driven applications.
So because when you put an item into the DynamoDB, it creates a record and actually
we can process it.
Yeah.
Good job.
And so let's skip these. Okay. And this is the actually code to interact with the DynamoDB. This has nothing to do with stream actually, and we're going to take a look at how to put a record and fetch that record in our demo, and this is the sample code for that. You actually create a client for it and give it a table name, and at that last create a new document, put the properties in it, and just call the put item method, and that document will actually be put in the DynamoDB.
Yeah.
So that was fast.
Yeah. Can I ask you a question?
So
we don't create a database like a relational database system, right?
Yes.
In DynamoDB.
Yeah.
We started the process to creating a table.
Mm-hmm.
So, can we say that DynamoDB is a part of your serverless architecture? What do you think?
Actually, yes, because as you said before, there is no database. DynamoDB is the only database you have, and you just create a table and use that in your maybe serverless application or whatever.
Just I need one table. I use it to store my IoT sensors data.
Mm-hmm.
So create it and then just write a function, and it can be a part of my serverless architecture.
Yes. Actually,
so it's demo time.
We're gonna create a table and put a data in it, and we're gonna try to fetch that item via. First, we're gonna create actually 2 Lambda functions for it, and we're gonna hook up a API gateway to fetch that data through HTTP requests, and we're going to create a console application to consume that data and actually provide that data. So let's get into it. I'll open up the Visual Studio. We're going to create a AWS Lambda function project. Before that, actually, we're going to have to create that table to